Okay, the last thing that we have to cover is polar form or trig form for complex numbers. So we've seen complex numbers like back in college algebra, we did them, and in algebra 1, algebra 2, you saw them. So a complex number is just any number of the form a plus bi. So you have a real part and you have an imaginary part. And you don't have to have both components. One of those could be 0. So I could say 2 plus 4i, that's complex. I could just say 2 because the imaginary is 0. Or I could say 4i, where the real part is 0. So what we're doing today is talking about how those can relate to the trig functions because they are connected. What we have not ever done before is graph complex numbers, but you can. You don't have the traditional xy axis. When you look at them, your horizontal axis or your x-axis is what's called the real axis. You graph your real numbers there. And your vertical axis or the y-axis is the imaginary axis. We are used to, when we talk about imaginary numbers, saying like a plus bi. And that's still true, but we could say x plus yi just because x is the real part, so we think about the x-axis. Y is the imaginary, so that's your y-axis. So today, instead of using a's and b's when I talk about imaginary numbers, I'm going to say x's and y's. Just kind of connect that to how we graph them, the real part being the x-axis, the imaginary part being the y-axis. And it'll also help us relate it a little more to our trig functions. Okay? So first example, I want to practice graphing those. So we're going to do a couple things. We are going to find the sum of two complex numbers. And then we will graph them and the resultant, which is just what you get when you add them. So if I want to graph 6 minus 2i, your x is 6, your y is negative 2. So we have 6, negative 2. And when you graph these complex numbers, they're like vectors. So think of it as going from 0, 0 to that point. Remember when we did vectors last week, we put that little arrow on the end. So this represents the vector 6 minus 2i. So negative 4 minus 3i. So my x is negative 4. My y is negative 3. What do you think you would get when you found the sum of these two complex numbers? So 6 plus negative 4, if you add the real numbers, you get 2. Negative 2i and negative 3i. So the sum, or the resultant, is positive 2, negative 5. And you notice that resultant, the sum, it fell in between the other two vectors, and that should always be the case. We're just going to kind of hit the basics today. So this is the first main thing. Are there any questions about how to graph these or how to add them? Second thing, we need to talk about how this relates to trig. Because obviously they put it in a trig textbook, there's some kind of connection here. So let's kind of review a few key pieces. we know that in our trig functions. Let's talk, let's go back x, y, and r. Remember the very first thing we talked about was that x squared plus y squared equals r squared? Watch it. So if you're trying to find r, that's the square root of x squared plus y squared. Okay, that's the same thing as the magnitude of a vector. When we were doing those last Thursday, the magnitude was the square root of a squared plus b squared. If you're just looking at a triangle, we did Pythagorean theorem to get this side. They're all connected. It's all the same thing. So that side r is still the square root of x squared plus y squared. All right, let's think about our trig functions for a second. If you do x divided by r, what is that? That's cosine. So x would be r times the cosine of theta. Y over r is sine theta. So y is r times sine theta. The other piece that we talked about with vectors, when we had to do those, we found the magnitude and the direction angle. Remember, to find the direction, we use tangent. So in terms of x, y, and r, tangent is y over x. So these are basically the four little pieces that we're going to use. All things that we've done since the beginning in trig. We cycled through and hit them again when we talked about vectors. One final time right now. So the trig form, or the polar form, is not what you're used to seeing. Okay, you are used to seeing a complex number being written as a plus bi, or I told you today we can think of it as x plus yi, right? That is what's called rectangular form, how we usually see those complex numbers. Polar form uses sine and cosine to represent them. So think about what we just wrote down. On the previous slide, what did we say x was equal to? X is r cosine of theta. Okay, what is y? And that one had an I with it. What do both of these have? Okay, we have the theta and they both have the r as well. So if you factor out the r, you get cosine theta. I'm going to write it as I sine theta. This is the polar form, or the trig form. Okay, the original, that I gave you right here, this is what we're used to seeing. That's called rectangular form. And then sines and cosines is polar form. So I told you there's three main components to it. The first one is just graphing those and being able to add them. So we've done that. The second and third is just going back and forth between these two forms. So first, I want to look at, if I give you something in polar form, can we write it back in rectangular? So let's look at one. So rectangular form doesn't have sines and cosines. So what do you think you would do? Yeah, don't we know cosine of 300? So 300 degrees, what quadrant is that in? Reference angle? 60. In quadrant 4, is cosine positive or negative? Positive. And what's the cosine of 60? 1 plus I times the sine of 300. So in quadrant 4, is sine positive or negative? Negative. And what's the sine of 60? So we have 2 times 1/2 minus I radical 3 over 2. So final step, just distribute the 2. 2 times 1/2 is 1 minus I radical 3. So to go from polar to rectangular, you just work out the sine and cosine. If it's values we know from the unit circle, then I expect the exact values, so the hand trick. If it was like 273 degrees, which we obviously don't know, we would use our calculator to approximate sine and cosine. Are those okay? Going backwards, there is a couple more steps that we need to look at. So if I start with something like 1 minus I radical 3, how do we get back to the sines and cosines? So there's really 3 steps that we have to do. The first one, I'm going to tell you to graph x plus yi. The purpose of that graph is really just to determine our quadrant, so that we will take the correct reference angle. Then we find r, and then we find theta. So let's look at one. So we're going to take the complex number and write it in trig form or polar form. Those are the same things. So first, let's graph. We don't need a real precise graph. I just really need to figure out what quadrant we're in. So the real part is a negative radical 3. So you go backwards radical 3. What's my imaginary part? 1. So what quadrant are we in? And that's all I really need my graph for. Now to find r, so you could think of it as magnitude or Pythagorean theorem, or if we wrote down r is the square root of x squared plus y squared. So x is your real part. Y is just the coefficient of I. So it doesn't include the I. This is just a 1i, so b plus 1 squared. plus 1, so it's square root of 4. And our r is 2. Next, we need our angle. This seemed kind of familiar. Didn't we kind of do this with vectors? We had to find magnitude and direction. And that's really what we're doing here. So tangent y over x, so that would be 1 over negative radical 3. Now tangent is negative in both quadrants 2 and 4, but we already know it's quadrant 2 from the picture. Reference angle. When is tangent radical 3 over 3? (30°). In radians, that would be pi over 6, and that's just because I said radian measure. So our angle, pi over 6 in quadrant 2, would be 5 pi over 6. So we have r, we have theta. So the final answer, the trig form, or the polar form, is r times cosine theta plus I sine theta. And we're not working it out. We're just leaving it with that sines and cosines. I want you guys to try this. Double check your picture. What's your real part? Yeah, this is like 0 minus 3i. So the x is 0, my y went down 3. So here's my picture. So then r what's x? Y is negative 3 squared. So what's r? 3. Theta, you could set up tangent, or you could just look at this. What's my angle? That's, so tangent y over x is undefined. So we're asking ourselves when tangent is undefined. Or if you look at your picture, what is the degree measure? That's 270. So trig form is r, so 3 times cosine of theta plus I sine of theta. Does that make sense? I feel like we need another one. I'm not confident that we're good yet. Oh my goodness. But you would probably like one that wasn't horribly ugly, right? That'd be a problem. How about let's do guys graph this to figure out your quadrant? What quadrant did it end in? 4, because you went over 4 and down 4. So we know we're in quadrant 4. Alright, R is the square root of x squared plus y squared. We don't need decimals though, we can keep it in terms of radicals. 16 plus 16 is 32. What can you break 32 into? So R is for radical 2. So that's, I prefer that over the decimal answer, just more exact. Now we need our angle. So we know tangent is y over x, so that's -1. Okay, the negative puts me in quadrant 4, reference angle. When is tangent 1? So 45 degrees in quadrant 4. So the trig form or the polar form is r times the cosine of theta plus I sine of theta. Is that one okay? So going the other way, what do we do? What quadrant is 225? Reference angle? Okay, quadrant 3 is cosine positive or negative. What's the cosine of 45? Plus I times sine of 225. And also negative. If you need to, you can rewrite that. So if you distribute your 5, you get -5 radical 2 over 2 minus 5i radical 2 over 2. So rectangular form is just a plus bi form. Polar form or trig form has sine and cosine. That is all we are doing, and I have a short handout.